Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Welcome to the SEI Podcast Series. My name is Suzanne Miller. I'm a principal researcher in the Software Solutions Division. Today, I'm very pleased to have my colleagues Joe Sible, David Svoboda from the CERT Division here to talk about a language that has some interesting security implications called Rust. Before we get into that, however, I know David's been with us before, but Joe, you haven't. So I'm going to ask each of you to just give a little bit of a bio and tell our audience what it is that's so cool about working at the SEI. Joe?
So my name's Joe Sible. I'm a software engineer on the Applied Systems team. My duties bounce around a lot. Sometimes it's just writing code. Sometimes it's helping fix our servers. I enjoy working here a lot. It's a great place to be.
Okay. What did you do before you came to us?
So this is my first job right out of college.
Oh, all right. So whatever we tell you is the way the world is.
Basically.
Okay. All right. I like that. David, you've been around a little bit longer than that. Tell us a little bit about yourself and your background.
Just a little bit. I actually joined back in 2007 or so with the secure coding group was just getting started, and they built the secure coding standards for C and Java and Perl and C++. So, one of the nice things I like about the SEI is that I'm a pretty smart guy, but there's lots of people smarter than me around that that can help me learn and adjust. Hi, Joe.
Speaking of smart people. All right. So we're talking about a language today, and there's probably hundreds of languages out now that have various functions. The one we're talking today is called Rust. And why is Rust important? And why is it a catalyst for more security-related work in comparison to some other languages? So I think, David, you want to start us off with that?
So in the big picture, there has been a lot of I tend to think of languages as competing with each other on the world stage, and lots of languages have kind of competed with C and with C++ kind of being the first contender. And what we discovered over the years is that most of these languages didn't really compete with C in the embedded world, where you have limited memory and your program needs to run really, really fast. Lots of languages, if you don't really need speed and performance, then you can use. They're easier. Python and Java are two good examples.
Yep.
So in the embedded world, C is almost completely dominant. C++ has a small niche role, but the other languages are pretty much absent in the embedded space.
All right.
So Rust is the first language that really looks like it can possibly compete with C in the embedded space.
So what you're telling me is we're done with Ada? For our audience that is younger than I am, Ada was a language that was promoted for embedded systems in the 80s, and it turned out to not be as good an idea as we thought it was.
Yes, it was a good idea in theory. In fact, I did apply for a couple of jobs in Ada back in the late 80s. They never managed to get Ada. They never managed to get C-level performance out of Ada.
That's a good way to say it.
You might say the safety guarantees that Ada offered killed its possibility of performance.
So we have a competitor to C after 30 years?
After 30 years.
After 30 years. So what is it about Rust that makes it a competitor to C?
So in the old days, you had C, which is dangerous but fast, and then you had a bunch of garbage collected and safer languages like Python and Java that were slow.
Okay.
Rust is one of the first languages, and the first one that's gaining significant traction, where it does a lot of checks at compile time to make sure things are safe.
Okay.
So at runtime, it's as fast as C, but it still gives you the same safety guarantees or better that the other languages have given you in the past.
Okay. All right. That's important.
And the main way it's done that is a thing called the borrow checker. That's basically the brilliant thing it's brought to the table, and even other languages like Ada are looking at picking it up because it's what's given it the ability for all the new safety. Everything stems back to that.
Okay. All right.
Perhaps if Ada had a borrow checker, it might have succeeded.
So tell us a little bit about what that is, if we've got people that aren't familiar with that concept.
Do you want to take this on, Joe?
Yeah.
You could probably explain it better than I do.
So the borrow checker basically enforces two rules. One rule is make sure programs don't try to use any memory after it's freed. That's a big source of vulnerabilities in C. And the second is make sure there's never two different parts of the program that can edit something at the same time.
Okay. All right. So those are things that are, secure coding practices. Don't use the memory after it's freed. Don't write to the same. You're basically giving tools that allow secure coding practices to be implemented, even if the programmer isn't as aware as they should be of those practices.
Right.
Is that
in
a fair
C,
statement?
we have secure coding rules saying don't do this.
Yeah.
And there's various analysis tools that will try and detect if you're doing that, but they don't always get it right. And so it's easy, it's possible, and unfortunately very easy for you to ignore the rules, and then you are in dangerous territory. And Rust, as Joe explained, tries to prevent that all at compile time, which means at runtime you can just worry about performance.
Yeah. No, I love that. And it, to my mind, it's like, why don't more languages do things at compile time? Because that's when you have the time, if you want to think about it that way.
C++ has been trying to do lots of things at compile time, but not security.
Okay. So let's move to talking about security specifically, because the blog post that you wrote recently is really about what are some of the security promises of the Rust programming language. So what kinds of issues did you explore? I know, Joe, you were involved in this piece in particular.
So the big piece of the blog post I went into was giving examples of C and C++ code with the kind of common mistakes that lead to security vulnerabilities. Then giving a transliteration of that code in Rust.
Okay.
And showing how the compiler won't even let you compile it until you fix them.
Nice. I like it. I like it a lot. I think I like this language. So you also looked at security limitations, because no language can do everything. So what are some of the things you ran into in terms of limitations to how Rust can help you with security issues?
Okay, so there are several ways of looking at that. First of all, of course, Rust has this notion of safety. And like Joe said, the safety prevents you from using memory after it's been freed, and it prevents you from race conditions, which is, two separate parts editing the same memory. However, there's many other things that people tend to think of as safety issues, such as it not depleting your bank account to $0 when it says if you have $1,000 in there. Or such as, say, if you do some floating point arithmetic and you wind up with the answer 4.9999999 and saying, is that equal to 5? Well,
depends on the context.
Right. The safety, that safety might be critical if you're talking about, if you're trying to figure out your rocket, when your rocket should cut power.
Right.
So Rust's notion of safety, it's internally quite consistent, and but it is, it doesn't necessarily match with your or my definitions of safety.
Right. And so there's any user of Rust needs to look at the context of use, and especially for embedded. A lot of our embedded software systems are very safety and security focused, so we have to be careful that we're not sort of ignoring the vulnerabilities that Rust still has.
Right.
Okay. All right.
One rule of thumb for what it fixes and what it doesn't. The kind of vulnerabilities that you only tend to see in C programs, the memory safety, memory corruption, it will take care of.
Okay.
Other vulnerabilities like forgetting an if the person's an admin check, it won't. It can happen in any language.
Sure.
Yes. In fact, one thing I noticed the top 25 CDBEs is a set of safety or security problems, and Rust only covers 7 of those top 25. The remaining 18 is still up to you.
Right.
A lot of them are web-based, so they're not the kind of things you encounter in C, and that's why it's so low. It would certainly be higher if it wasn't focused on web issues.
And just for our audience that don't know what CWEs are, explain that acronym for a minute. That's okay.
CWE is Common Weakness Enumeration. It is sort of a way of partitioning the set of all vulnerabilities into subcategories. So there's one CVE for use after free, and there's one for, say, dereferencing null pointers. There's several for buffer overflows. There's a whole bunch of category CVEs, like here's one for just general code quality issues. So it's a common way. It's a lot like the CERT secure coding standards of identifying vulnerabilities. However, CVEs, unlike CERT standards, have become widely known in the DoD company.
That's something that we can reference in the transcript if people need more information about those.
Right.
So are there other things about about Rust that you want potential users to know about. Some things that are really cool about Rust, or some things that you go, and by the way, don't ever try and use it in this context. Things like that would be interesting for our audience.
So yeah, to build on what David was saying about null pointer dereferences as a CWE, so the concept of null is, these days, it's called the $1 billion mistake. That refers to there's an estimated over $1 billion worth of productivity lost and problems caused by the fact that null is a thing that exists.
In C and Java,
right,
and Python and so many other languages.
So Rust is fixing the $1 billion mistake. They don't have a general concept of null that anything can be, unlike C where any pointer can be null,
right.
Java where any object can be null. In Rust, by default, everything has to have some valid value of the type in it. If you want something to be optional, you have to wrap that thing in an option. Then it can either be none, the equivalent of null, or some if it has something in it. And the compiler enforces, for types that are wrapped in option, that you check it everywhere before you use it, and for types that aren't, that there is always something in it.
So we're trying to take the $1 billion question down to maybe a few cents.
Yeah.
Yes.
I like it.
There's a maintenance cost that you have to get your program to work right, but then you're not going to have to worry about null pointer dereferences or anything like that again. Okay.
All right. So that could be useful in some settings. Are there settings where you would recommend against using Rust?
There are. So as we've said, Rust is a very performant language and uses little memory. But if you're, say, using Java and you're happy with it, you're happy with the slower performance and the greater memory usage, then you would probably not be happy working with Rust. Rust does impose a cost on you, a maintenance cost of making sure that your memory is freed when done, and you don't have race conditions and use after free problems. This does impose some maintenance overhead, which Java and Python do not impose.
Gotcha.
So if maintenance is the most important thing for you, more than security or performance, then you would not be happy with Rust.
All right. So thinking about new users to Rust, what kinds of things that we have done at the SEI or that you want to reference externally would help them to get familiar with Rust and help them to understand if Rust is relevant to their situation? I know we're going to be doing some other things with vulnerabilities on another podcast related to this. So really just focusing on what are the things that users have available to them to become familiar with using Rust productively.
What's it, rustlang.org?
Yeah, rustlang.org.
That's definitely the place to start. It has an extensive reference manual. I enjoyed the Rustling course, which is actually a project on GitHub with about 100 small Rust programs. Each one has some failure, and your job is to find and fix the failure. And it has a server that simply detects when you change the file, so that it tries to run it and say, this program is still not working, or this program is working. Congratulations, you could move on to the next program.
So a little gamification going on.
Yes, it gamifies the learning process.
Okay.
And then Rust documentation is excellent. So rustlang.org, as David said, it's not just a reference.
Okay.
There's also a Rust book, which is an introduction. It's almost like an introductory course you walk through. It has live code examples in the book you can run in place and follow along with.
Nice.
There's also Rust by example, which is a little bit more practical and hands-on. Teaches you the same thing. Both are very much worth going through.
Okay.
That's all it took to teach me Rust.
Okay.
I didn't need any formal course beyond that.
All right. So we will make sure that all of those are referenced in the transcript so that people don't have to take notes while they're listening.
Our blog post did cite Rust, rustlang.org.
Good. So Rust is a new language. You've been working with it. What else are you researching? What is next for each of you in terms of either Rust-related work or other work in your security areas that you're both working in? David?
So for me, this is not exactly Rust-related, but my main project now is a automated repair system that can say, hey, you have a null pointer vulnerability in line 10. Let's just fix this automatically so that the program will never complain of a null pointer again.
Right.
And if you have like 1,000 null pointer vulnerabilities, it fixes all of them at the time. This is a 2-year MTP project that I'm working on. Hopefully, in 2 years, we'll have a program. We'll have a tool that can do that, and that will be useful to the DoD.
In particular, yes. Although that's still useful to a lot of other people that do embedded software.
Yes, but the SEI's one of the SEI's main mission is to serve the Department of Defense. So that's why I'm focusing on them.
And just for those that don't know, an MTP is a particular type of research project here at the SEI. Mm-hmm. So, Joe, what about you? What are you working on?
So my next security topic that I might do a blog post or podcast about, also not really related to Rust, is looking at ways to keep network middle boxes from telling what websites people are going to. And the upcoming keywords for that, the technologies in use, DNS over HTTPS and encrypted client hello.
Okay. Encrypted client hello. I like that.
Yep.
Non-encrypted client hello world.
Yeah. Yeah.
Both of which Cloudflare is kind of the driving force behind today.
Okay. All right. So we have something to look forward to. I really want to have a podcast that's titled Encrypted Hello. All right, I want to thank both of you for joining us today and talking about this. I think that understanding that there are alternatives, especially to sort of our standard, embedded software language C, is important to people who are trying to make more secure and safer code. So I think there'll be a lot of interest in this out in our community. And I will look forward to future times when I'll be able to talk to you about other kinds of things, your automated repair and the kinds of Cloudflare research things that you're getting into, Joe. So thank you very much. And I want to remind our audience that you can get this podcast anywhere that you get your other podcast. You could get it on SoundCloud. You can get it on Apple. You can get it on my personal favorite, the SEI YouTube channel. So I hope that you will access this work and that you will get benefit from the work that these guys are doing. And with that, I will say thank you.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, Stitcher, TuneIn Radio, Google Podcasts, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.